On the basis of molecular composition, acids as classified into two categories. Especially, you may have seen that few acids do not contain oxygen, few acids contains oxygen. Hydroacids are the acids which containing hydrogen and non-metals other than oxygen. Example, other than oxygen, HCl belongs to the hydroacid, HBr belongs to the hydroacid, HF belongs to the hydroacids, Hi, hydrogen iodide, belongs to the hydroacid. In the same way, oxyacids means the acids which containing hydrogen is a common atom, and another elements like another elements, it may be non-metals only almost, another elements are non-metals including and oxygen, including oxygen, such as for example, such as which are the acids which contains the oxygen means nitric acid, HNO3, H2SO4, sulfuric acid, H2CO3, carbonic acid, H2PO4, phosphoric acid. All these belongs to the oxyacids, including the organic acid like CH3COOH, formic acid like HCOOH. Why? Because these acids contains oxygen. There's the two different types of acids, hydroacids and oxyacids, based on the molecular theory. Now, let us move to the next concept of how the acids has been classified on the basis of strength. On the basis of strength of an acid, acids has been again classified into strong acids and weak acids. Basically, you must remember the strength of an acid always depends on the concentration of hydronium ion present in the aqueous solution. Strength is always depends on the concentration of hydronium ion. That means, so strength of an acid, strength, based on the strength, we have classified acids into two categories. Based on the strength, we have classified acids into two categories. One is strong acids and weak acids. So strength is always depends on the number of ions. That means what? If the more number of ions are there means more number of H3O plus ions are there means, then that is what we call strong acid. If we have very less number of H3O plus ions, that is what we call as weak acid. The strength is very less here, or strength is very more here. Okay. Now let's start with the definition of a strong acid. Strong acids are the acids which dissociates almost completely in the aqueous solution. When you dissolve an acid in water, thus that acid completely dissociates to give maximum number of ions, like more number of H3O plus ions should be produced. So that means, according to this definition, so we can define the strong acids as acids which dissociates, acid which dissociate almost completely in aqueous solution. That is what we call it as, strong acid. When acid which dissociates almost completely in aqueous solution, thereby it produces high concentration of ions. Which ions? High concentration of H3O plus ions. That is what we call it as strong acids. And strong acids always gives you more number of H3O plus ion. What are the examples for strong acids means? Let me give you strong acid like HCl, H2SO4, HNO3. These are the strong acids which almost completely ionizes to give the main particles called as ions. Mainly they produces ions. So they may ask you in the examination by giving any one formula of this. So the type of particles present in the sulfuric acid is the particles are mainly ions. And let us discuss now. So acid which partially dissociates to give less number of ions. Why it gives less number of ions? Because it is undergoing partial dissociation. For example, suppose if I take 20 molecules of HCl, it is impossible to take only 20 molecules of HCl. If I take 20 molecules of HCl and if it dissolved in your water, the HCl produces 20 hydronium ions and chlorine ion. Almost they dissociates. But if I take the same 20 molecules of CH3COOH dissolved in your water, see 20 out of 20 molecules, approximately 4 to 5 molecules, very few molecules dissociates to give their ions. Okay, and remaining around 15 to 16 molecules of CH3COOH, they retains their molecularity in the solution. They retains their molecularity in the aqueous solution. That means we have added large quantity of acid, but only few molecules of acid undergoing dissociation to produce very less concentration of ions. Hence the reason these particular acids are called as weak acids. Example for this is acetic acid. Acetic acid, almost organic acids or weak acids. Almost organic acids or weak acids. This is the concept of acid. This is the concept related to the strong acids and weak acids based on the strength. So I hope it's clear to all of you. Now let us move to the next slide. Based on the concentration of acids, again the acids has been classified into two categories. One is concentrated acid. Another name is dilute acid. Dilute acids. So in the laboratory, most of we use this dilute acids for doing some kind of experiments. So what is the difference? Very simple. So if you dissolve 50 grams of sugar in 50 ml of water, then we'll consider this is concentrated sugar. 5 grams of sugar to the 50 ml of water, the sweetness of the sugar solution is very less. Then we'll say that this is what diluted one. So dilution is depends on the acid present in the solution and quantity of water present in the solution. Is it clear? So I hope you understand that concentrated acids have relatively high percentage of acid. Concentrated solutions means concentrated solutions have relatively high percentage of acid. High percentage of acids. In where? In aqueous solution. In its aqueous solution. Aqueous solution is nothing but in water. That's all. So for that is what we call as concentrated. For example, let me take one beaker and let me add 90 ml of water and 10 ml of acid. This is 90 ml of water is there. Water, only 10 ml of acid I have added. Then this we will consider as a dilute acid. Dilute acid. Now in the beaker, if I use 90% of 90 ml of acid along with 10 ml of water, then this is called as concentrated acid. Then it is considered as a concentrated acid. I hope you understand the concept. So now, how can you define the dilute acids? Means relatively the low percentage of acid in aqueous solution. So that is the concept. Now let us move to the types of acid based on the basicity of an acid. Before going to the classification, we'll learn about what is the meaning of basicity of an acid. Basicity of an acid. What is the meaning of basicity of an acid? For example, if we take one molecule of hydrochloric acid, one molecule of hydrochloric acid, to neutralize this hydrochloric acid into NaCl plus H2O. So how many molecules of base is required? How many molecules of OH ions are required? Based on this, we can give the basicity to the acid. Here, to neutralize one molecule of HCl, we required one OH minus ion. Then the basicity of HCl becomes 1. This is the meaning. So otherwise, you can also define that basicity of an acid, the number of hydrogen ions which can be produced per molecule of an acid. For example, here you can see that there's a one molecule. It produces only one H plus ion and Cl minus ion. So hence the reason basicity is 1. And also with the another definition, one more definition is there, the number of hydroxide ions with which one molecule of an acid can combine. That is what also called as basicity of an acid. That means here you have seen here one molecule of an acid can react with only one hydroxide ionic base. Then HCl basicity becomes 1. That is the meaning. So based on the basicity, now we have classified the acids into 3 categories. One is monobasic acid, dibasic acid, and tribasic acid. Based on the basicity, we have classified the acids into monobasic acid. Monobasic acid. What is a monobasic acid? Monobasic acid is the acid when it is ionizes in a aqueous solution, when it dissolves in a water. The acid, one molecule of acid produces only one replaceable hydrogen. Means the acid, when it dissolved in a water, it produces only one hydrogen ion per molecule of an acid. That is what we call as a basicity or monobasic acid. Otherwise, acid contains one replaceable hydrogen ion. In a solution, if it contains only one replaceable hydrogen ions per molecule of an acid, when it is dissolved in water, then that is also called as monobasic acid. That is what we call it as monobasic acids. Examples. Let me take HCl, hydrochloric acid. Hydrochloric acid is a monobasic acid. Why? Because this hydrochloric acid has a formula of HCl. When HCl is dissolved in a water, it produces only one hydrogen and chloride ion. And hydrogen combines with the water and it forms a hydronium ion like this. So that is not a big issue. Hydrogen ion in aqueous solution or hydronium ion, both are same. So generally I can write that HCl, when it reacts with the water, it produces H3O plus Cl minus ion. So here it producing only one hydrogen. Hence the basicity of HCl is 1. And one more point you're supposed to remember, the basicity of HCl is 1. Hence the reason this particular monobasic acids always produces a normal salt. The monobasic acids forms only one kind of salts called as normal salts. Normal salts are the salts which do not contain hydrogen. Example, let me take when HCl treated with NaOH. Always neutralization reaction produces salt. This salt is normal salt with the liberation of water. So here the NaCl acts as a normal salt. The same way when I check the CH3COOH, when it treated with the NaOH, it produces CH3COOH plus H2. Here acetate, sodium acetate, also a normal salt. And now children, You may get confusion here because this CH3COOH, how it considered as a monobasic acid. Acetic acid has 4 hydrogen atoms in it, but it ionizes only 1 hydrogen in aqueous solution. Why? Because let me show the structure of an acetic acid. Acetic acid basically forms a covalent bond between carbon-carbon and carbon hydrogens. So the bond strength between the carbon and hydrogens are very strong. And bond between the oxygen and hydrogen is very weak compared to the bond between hydrogen and carbon. Hence the reason when it dissolved in your water, suddenly it breaks this hydrogen and makes the acetic acid into CH3COO minus plus H plus ion. Acid, when you treat it with water, it becomes aqueous solution. In aqueous solution, the ions present are acetate ion and hydrogen ion. Now, this particular CH3COOH, when you treat it with a NaOH, other some bases. Now, this hydrogen combines with the hydroxide of NaOH and it forms H2O and CH3COON. I hope you understand, children. So acetic acid, even though if it contains 4 hydrogen, it behaves as a monobasic acid because in the acetic acid, only 1 hydrogen gets ionized. That's all. So you have to conclude that acetic acid, even if it contains 4 hydrogen ions, but when it dissolved in your water, it ionizes to give only 1 hydrogen per molecule. Hence the reason acetic acid is considered as a monobasic acid. Now let us go to the next type of acid called as a dibasic acid. B. So dibasic acids are the acids which ionizes in aqueous solutions to produce 2 hydrogen ions per molecule of an acid. That is what we call it as dibasic acid. Basically, the examples for dibasic acids are H2SO4, H2CO3, H2SO3. These acids, you're supposed to remember, these acids undergoes dissociation in aqueous solutions to produce 2 hydrogens in 2 different steps. That means they dissociate 2 hydrogen atoms, 2 hydrogen ions in 2 different steps. Hence they may leads to the form 2 different kinds of salts. For example, H2SO4, when you ionize in your water, H2SO4 ionized in your water, H2SO4 leads to form H plus and HSO4 ion in first step. And this HSO4 minus ion again further dissolves in one more water and it releases another hydrogen and it forms a SO4 2 minus ion. That means this is in second step. So here it produces one H plus and here it produces one more H plus. Together in 2 different steps it producing 2 H plus ions. So overall I would like to write here the H2SO4 dissociates to form 2 H plus ion and SO4 2 minus ion. But this takes place in 2 different steps. Step 1, it gives first 1 hydrogen and it gives you acidic ion. This is actually acidic ion because of it contains a H plus. Let us start with the example of dibasic acid, sulfuric acid, how it produces the salts. So dibasic acids forms 2 different salts. Which are those salts? Means acidic salt and normal salt. Acidic salt which contains hydrogen, whereas in normal salt all hydrogens are replaced. There is no hydrogen in normal salt. Let us study with an example now. When H2SO4 treated with insufficient NaCl, if I take, the sodium displaces only one hydrogen and it produces NaHSO4 plus HCl. You can see here, due to the presence of the hydrogen, the salt behaves as acidic property, as we can call this is acid salt or acidic salt. And in second step, same acid salt NaHSO4 again treated with a NaCl, it may displace again the sodium displaces the hydrogen and it forms a Na2SO4 plus HCl. So this is called as a normal salt. And acidic salts are forming in step 1 reaction, and normal salts are producing in step 2 reactions. So overall reaction, if you want me to write, when H2SO4 treated with excess of NaCl, excess of NaCl, that means 2 molecule of NaCl, then finally we'll get a Na2SO4 plus HCl. So this is on kind of the reaction, but here you must should remember, here we are going to maintain the temperature conditions. Here when you maintain below 200 degrees centigrade, we'll get acidic salt. When you maintain above 200 degrees centigrade, we'll get directly normal salt. Let me take one more example if you want it. Let us study with some more examples. What happens to the sulfuric acid treated with insufficient NaOH? Sulfuric acid is being a dibasic acid when it treated with the sodium hydroxide. So obviously you know that this is a generally neutralization reaction. So it gives you salt plus water. Which salt here will get means sodium sulfate salt. Let us see now. So when sulfuric acid treated with hydrochloric acid, when sulfuric acid treated with insufficient of NaOH, it will gives you insufficient. We have taken here as the reason the sodium can displace only one hydrogen from the sulfuric acid. It forms a NaHSO4 plus H2O. So here, due to the insufficient NaOH we use, here it produces acidic salt. That means somewhat acidic properties are gained by this particular salt. So due to the presence of hydrogen. Now, same thing when you treat this H2SO4 with excess of NaOH. H2SO4 with the excess of NaOH, for example, excess of NaOH, for example, 2 NaOH. So there are excess of sodium hydroxide molecules in the solution. So 2 molecules contains 2 sodium ions. Sodium ions displaces completely hydrogen from the sulfuric acid and they forms a normal salt Na2SO4 displacement of 2H2O. So these are the examples for dibasic acids. So again here, one note point you're supposed to remember. I have given already the dibasic acid examples. I have given the sulfuric acid, carbonic acid, and phosphoric. Let me give you one question, children. The phosphoric acid is considered as a dibasic acid even if it contains 3 hydrogen in it. Why? If you know the answer, just answer in the comment box. Let us continue with the next type of the acids, that is tribasic acids. Tribasic acids are the acids which ionizes in aqueous solutions to produce 3 hydrogen ions per molecules. Tribasic acids ionizes in aqueous solutions to produce 3 hydrogen ions per molecule of an acid. It contains 3 ionizable or replaceable hydrogen ions per molecule. Example, phosphoric acid H3PO4, and 1 molecule of phosphoric acid ionizes to produce 3 hydrogens in 3 different steps. So in the step 1, phosphoric acid, when you treat it with the water, it ionizes to produce H2PO4 1 minus charge along with one hydrogen gets separated. In step 2, this H2PO4, this H2PO4 minus 1, when it ionizes with one more water molecule, it produces HPO4 2 minus ion plus one more hydrogen. And finally, in step 3, HPO4 2 minus ion ionizes to form PO4 3 minus plus H plus ion. Overall, in first step it releasing one hydrogen, second step it releasing one hydrogen, third step it releasing one hydrogen. Overall, I would like to say that H3PO4, when it dissociates or when it dissolved in a water H2O, it releases three replaceable hydrogens. Let us study this phosphoric acid reaction with sodium hydroxide. H3PO4, when it dissolved in one molecules of NaOH, insufficient molecule. In sodium hydroxide, only one sodium is there. Sodium can displaces only one hydrogen from the phosphoric acid. Hence the reason here you will get NaH2PO4 compound plus H2O gets separated. So this is takes place in a first step reaction, and this is actually the acidic salt because this contains two replaceable hydrogens. Now let us treat same salt with H3PO4 with two molecules of NaOH. When you give two molecules of NaOH, that means it is taking in a second part. So it two molecules of NaOH, two sodium displaces two hydrogens, and it forms Na2HPO4. Na2HPO4 plus H2O will form. This is in the second step. In the step 2, second step, it produces one more salt. This is called as disodium hydrogen phosphate or biphosphate. So here disodium hydrogen is present, hence this salt also considered as a acidic salt. This is in second step. And overall, if we treat H3PO4 with excess of sodium hydroxide like three molecules, excess, it will completely displaces all hydrogen from the phosphoric acid and gives you Na3PO4 compound by the replacement of 3H2O. This salt is normal salt because there is no hydrogen ions. Finally, the reaction will stop at third step. Is children. So this is about the dibasic acid, monobasic acid, dibasic acid, and tribasic acid. And here the tribasic acids have basicity of 3. Why? Because it produces 3 replaceable hydrogens. And above I have given one question to you: why phosphoric acid considered as a dibasic acid even it contains 3 hydrogens? So answer is, the structure of phosphoric acid looks like this. Looks like this: H3PO3. Listen children, here in the phosphoric acid, two hydrogens are connected to the oxygen. Because of the weak bond, they can easily ionize to form their respective ion. Whereas hydrogen which is connected directly to the phosphorus nanometal, this forms a strong covalent bond. It will not ionize easily. Hence the reason the two ionizable hydrogens only present in the phosphoric acid. Hence it is called as a tribasic acid. I hope you understand the entire concepts of acid, meaning of an acid, types of an acid based on different sources. So I hope this video helps you to learn more about the acids. If you like my video, just subscribe my channel and hit the bell icon and share with your friends to learn acids, base and salts. And I hope you will wait for my second video. Thank you very much.